All right, welcome back to Number Sense Academy. And in this video, we're going to talk about factoring, binomials, and trinomials. So, factoring, binomials, and trinomials. So, binomials, they are expressions with two terms. And for example, you have ax squared plus bx. There are only two terms. Sorry, not the plus part of it, just the bx part of this one. Okay, and in this case, the type of factoring that you can do is kind of limited. You can only do what we call the greatest common factor. So you look for the term that's common in both terms, and you pull that out, and then you write it as a product. And then we have trinomials, which have three terms. And when we say three terms, so if I have ax squared plus bx plus c, this has three terms. Ax squared, bx, and c. And you can already see that this is a familiar type of expression. It's called a quadratic. And when you're able to factor a quadratic equation, or this trinomial, you're able to pull out certain properties that make it easier to interpret and analyze a quadratic equation. Now, I don't want to get too deep into this term aspect of it, but ax squared plus, or maybe let's use a real number for a in this case. So if I have 3x squared plus 2x squared plus 3, essentially this is a binomial because these two terms are like terms and we could combine them to get one term. So I have a binomial. This is not a trinomial. Okay, so when we talk about binomial and trinomial, we're talking about terms like distinct terms in simplified form. And in this case, we have a quadratic equation. It's a trinomial. And in this case, we have a binomial. So what do we mean by factoring? When you multiply two numbers together, you end up with a product. So if we go 3 times 6 equals 18. So 18 is the product. The factors of 18 in this case are 3 and 6. Now we know that there are other factors of 18 because I know that 6 has factors 6, 1, 2, and 3, which means that these are also applicable to 18. But when I factor, what we're really doing is writing a product as an expression of its factors. So we're expressing a product in terms of its factors. So instead of saying 18, which I know is a product, I just write it as a product of its factors. So just by looking at that, I know it's 18. Another way of doing that is 9 times 2, or I could write 18 times 1. So these are all product or the factors written as a product. Okay, so the formal definition of factoring would be the process of writing a number or expression as a product of factors or of its factors. Okay, and there's some key terms in there. And one of the ones that I want you to pay attention to is the term product, right? So whenever you write out in something in factored form, you're actually writing a product. So you're multiplying. There's no plus sign sitting in between. So, for example, if I give you ax plus bx. If I factor this, so this is the product. Writing it as a product of its factor is going to be x times a plus b. All right. So we see that x, open bracket, a plus b, close bracket. So this is a product. This is saying x times a plus b, or a plus b times x. You cannot stick an operation in between those. No. If I have x and I put a minus sign, a plus b, this is no longer a product. This is a sum of two terms or three terms, a plus b and then x minus a plus b. So you're not allowed sticking operation signs in between the terms or the factors. Because if you do that, it's no longer multiplying. And that's very important. Okay. So let's look at some types of products that you're going to come across. One of the more basic ones would be something that looks like this, ax plus ay, which you already kind of alluded to. When I factor this, I'm going to end up with something that looks like this. And basically, all we're really able to do is take out the greatest common factor. This is the most basic part of factoring. And this is a skill that you have to have in all things. You got to be able to recognize the greatest common factor and see where that's applicable. Even when you do more complicated factoring, as we're going to get into later on, it's important to see if you can pull out a GCF. Yeah, short form is GCF. Okay, and what do I mean by greatest common factor? Let me look at a quick example. So if I have 24x plus 12y, okay, and I say, okay, well, 24 and 12 are even, so I could remove a 2, or I could write this as a product where 2 is a factor. So I'm going to have 2 times 12x plus 6y, right? And if you were to re-expand these, right, I'm going to 2 times 12x. Using the distributive law, I'm going to end up with 24x plus 12y. So that's the key thing. If you write in factored form and then you re-expand, you should get back where you started. Well, here's the deal. If I look inside the bracket, the 12 and the 6, those are also even numbers, so I could divide by 2 even more. So if I bring out a 2, I'm going to end up with 2 times 2, and then this would be 6x plus 3y. Okay? But if I look in the brackets again, there's 6 and there's 3. Well, 3 goes into 6 and 3 goes into itself. So what I end up with now is 2 times 2 times 3 times 2x plus y. Oh, I forgot the bracket here. So 1, 2, 3 brackets. Okay? So if I multiply everything out front, I have 2 times 2 times 3, that's 12. 12 times 2x plus y is my final answer. This is actually the greatest common factor. So you don't stop factoring until you end up with the greatest possible number that could be factored out of your terms. Okay, so that's very key. So that's probably one of the more easier ones. Let's look at another one where we have, say, a term squared minus another term squared. This is called a difference of squares. All right, and these, the reason I even mention it, they should be easy to spot. If you have a difference of squares, in factored form, it's simply x plus y times x minus y. And because we're multiplying, the order doesn't matter, so you can still write it as x minus y, x plus y. It's the same thing. Okay, so if you have, and we'll get into an example later on, but if you can recognize that you have 2 squares and you're subtracting 2 squares, then you want to end up with something of this form. Actually, you know what? Let me do an example right now, just because I want to illustrate something. So if I have x squared minus 16. Okay, so I know that x squared is the same as x times x, right? And then I know that 16 is 4 times 4. So using the format over here, I could just write this as is in factored form. It's going to be x plus 4 times x minus 4. Right? So I know I said difference of squares, but if you're familiar with this, if you take the square root of a number, any number, take the square root of any number, and then you multiply it by the square root of that same number, you're going to end up with that number, right? So essentially, you could really have a difference of squares of anything. It's just that it's how you express it. So if I have x squared, if I had x squared minus 15, I could actually write this as a difference of squares. I'll just write it as x minus the square root of 15, or x plus, and then x minus the square root of 15. Okay, and this is just kind of an early tip. You're going to come across this in your math classes somewhere. Just keep this in mind that you can take a difference of squares of anything, as long as you really don't need to go and find the actual square root. Just express it in the radical form, and that's good enough. All right, another example. If you're able to spot an equation or an expression in this form, 2xy plus y squared, then what this becomes is just x minus y times x minus y, which is the same as x minus y squared. Right? But in order for this to be true, you have to be able to spot this. So the way you'd spot it, you'd look at the y value and see if that's a perfect square, say 25 or 16 or 4 or 9 or 64, 81. And then you're going to check the middle value to see, well, okay, so if these are perfect squares, then you know that the square root of, say, 25 is 5. 16 is 4, 2, 3, 8, and 9. So if you know that these are the square roots of this perfect square, the middle number should be a product of 2 times the number in front of the x, which would be somewhere here. In this case, it's 1. And then whatever the square root of y squared is. Okay? And in this case, will be y. Okay? So if you can spot that and recognize it right away, then you could jump to writing your answer in this form. Again, it takes a bit of practice to be able to see that. So if you don't see it off the bat, then just follow the methods that we're going to show you later on, and you'll still get your answers. Like similar to that, we have x squared. We have x squared plus 2xy plus y squared. And this is the same as x plus y times x plus y, which is the same as x plus y squared. Again, same thing. If you're able to spot, a number that's a perfect square, and then if you say, okay, if I take the number in front of the x and I multiply it by 2 and then multiply it by the square root of the perfect square, and I get this number in the middle, then you could just quickly jump to your expression as this. Okay, but it does take some practice to be able to spot these. Before I jump to the next one, I just want to point this one thing out. X squared minus y squared is not equal to x minus y squared. And you could solve these yourself and work it out. So remember, x squared minus y squared is factored as x plus y times x minus y. X minus y squared is just simply x minus y times x minus y. I remember screwing this up when I was in high school. I just thought they were the same thing for some reason. They're not, but it's a very easy mistake to make, and I'm just saying it, don't make that mistake. Okay, the most basic form of question that you'll get will be in this form. So let me erase this real quick. The most basic form, you're going to get it like x squared plus a plus bx plus b times d. That, sorry, not b times d, a times b. Every single um, trinomial follows this pattern. Every single one of them. So if I had, because we have ax squared plus bx plus c. So it follows the a, b, and the a. It all follows from this, right? Where there's a in front here, you just don't see it, right? All it's saying is that uh, if I take a and b and multiply them, I'm going to end up with this number, with c. And this is about factored form, okay? So actually, let me just specify. So we're talking about x plus a times x plus b. Because if you were to actually expand this, if you were to expand it, so I'm going to go x times x, x times b, a times x, and a times b. So I get x times x, right? Then I get x times b plus x times a plus ab. So this is going to be x times x, but this has an x in common, so it's going to be a plus b times x plus ab. So in expanded form, this is what I have. So whenever you want to factor, really what you're trying to do, you're trying to find this number is a product, AB, and those same numbers, the number in the middle is a sum. Okay, so that's the most basic rule you have to follow. And it applies to all of when you're factoring trinomials, and the examples that we're going to go through, where we'll see how that plays out. Now, a more complicated side of this is when you actually have a number, when a actually has a value greater than 1, or a value that's not 1. Maybe not greater than 1. It could be negative as well. As long as it's not 1. So if a is not 1, right? So that kind of throws a wrench into the whole pie. So what ends up happening now is if I have something that looks like this, and the reason why it looks like this is because this is the result of what you're going to get when you expand, or when you simplify, or actually complete, when you actually solve or find the product. Okay, so really what you have is ax plus b times cx plus d. So if you follow the rules of expanding, you're going to end up with ax times cx, which is this value, so the x's become squared. Then you have ax times d, then you have b times cx, and then b times d. So the b times d ends up here, and then the middle number, the middle number is going to be ax times d, b times cx. And then we factor out the x, so that's how you end up with ad and bc. Right? So do you have to memorize this? No, you don't need to memorize this, but it's just really understanding the pattern. All right, so let's jump into some examples right now. So first example, we have 15 x plus 3. Okay, this is a binomial. We're not given much, but we know that we can take out a greatest common factor. And right off the bat, I can see that 3 is common to both of these. Okay, and just a quick tip, if you want to know if 3 is common, then any number that where you take their digits and you add them together and that result is divisible by 3, then the number is divisible by 3. So for example, 1 for 15, I have 1 plus 5, that's equal to 6. Well, I know 6 divided by 3 is 2, so that works. So therefore 15 can be divided by 3. So if I have 1001 or 10,011, because this adds up to 3, this is divisible by 3. This number is also divisible by 3. And if you don't believe me, check it out. Just because the digits add up to 3. Okay? It's just a standard rule. So we're going to take out a GCF. That's all we can afford for this one. And we know that it's 3. So I'm going to write it in distributed form or in factored form. So it's going to be 3 times 5x and then plus 1. And then just to do a quick check to make sure it works. So you have 3 times 5x is 15x, and then 3 times 1 is going to be 3. Or 3 times positive 1. So that checks out. All right, another example. So what if I have 7x cubed plus 21x squared, and then minus 14x? All right, so the thing that's jumping out at me right away is the 7. The 7, the 21, the 14. I know that those are all divisible by 7. Okay, so in this case, the first thing I'm going to do, I'm going to pull out the greatest common factor. So what I end up with, the greatest common factor for 7, 21, and 14 is 7. So I have 7, then I have x cubed, then I have 21, no, not 21. It has to be 3, so 3x squared, and then minus 2x. So remember, you always got to be attentive to the sign. I also notice that x is common in all of these. I have an x cubed, I have an x squared, and I have an x to the 1. Always take the lowest of the x's, because if I were to take out x cubed, that means when I multiply 7x cubed by 3, I'm going to end up with 21x cubed, but I really only have 21x squared. So it has to match. So I have to take out the smallest x. And what I end up with is 7x, right? And then this becomes x squared plus 3x and then minus 2. Now, this is in a form that is possibly factorable. I could factor it some more. Just off the top of my head, it doesn't look like I could use conventional methods. I might have to use a formula to factor it. So if you get this far, we can leave it there. Okay, another thing that you should probably pay attention to that might pop up is factoring by grouping. Okay, so this is similar to the GCF one. I'd be attentive to this as well because it could make your life a lot easier. Just being able to spot it. So if I have 2x minus 2y plus ax minus ay, I could see a lot of GCFs happening. You just have to know where they are and find them. So let's map them out. The first one I see is, okay, well, I have a 2 here and I have a 2 here. So I could probably factor out a 2 from here and here. Great. Next, I have an x here and I have an x here. So I could factor out an x by grouping the 2x and the ax. Third, I have a minus 2y and a minus ay. So I could factor out a minus y or a y, depending on what I feel like taking out. And then I also notice that I have an ax and a minus ay. So I could also factor out the a's there. So let's start by what we see first. So I'm going to start by just taking the groups that we have. In this case, 2x minus 2y, I take the 2 out and I have x minus y left. And then over here, I take out the plus a because it's common, and I end up with x minus y. Now, what do you notice? Since I'm writing these terms as a product of factors, x minus y is now a common factor to both of these factored forms. So which means I could write it as x minus y, kind of like the distributive rule, x minus y, what's left? I have 2 plus a. Okay? So that's one way. Now, what if I was to reorder the group? Maybe I didn't spot it right away, and I said, you know what, I want to focus on the x's. So I have 2x, I'm going to rewrite it to fit the x's. I have plus ax, then I have minus 2y, then I have minus ay. So off the cuff, off the bat, I'm going to factor out the x's. So I have x times 2 plus a. And then for the other part, I'm going to factor out a minus 2. So I have, well, not, sorry, not the 2 is not common. The y is common, right? So I'm going to factor out a minus y because I have 2 minus signs. So minus y. And what I left is, I'm left with a 2, and I'm left with a positive a. Okay? A little bit tricky there, but you really have to be attentive to those. And then we're back to where we were at the end of the last question, where we had 2 plus a was a common factor. So I'm going to take that out. So I end up with 2 plus a, and I'm left with x minus y. And these look the exact same. They're just reversed. So another thing to watch for is factoring by group, and that can help. All right. So how about this example? We have x squared minus 9. So you should already spot that 9 is a perfect square. This is 3 times 3. And this is x times x. So we have a difference of squares. Difference of squares. So that just quickly becomes x plus 3 times x minus 3. And there's nothing much to do there. Another quick example. So what if I have 4x squared minus 16? I look and I see that the 4 is 2 times 2. The x is x times x, and the 16 is 4 times 4. Okay? So these are all perfect squares. So I can just use the difference of squares. So this becomes 2x minus 4, or plus 4, and then 2x minus 4. All right. The only issue here is that I see a 2, a 4, a 2, a 4. So I can factor some of this. So this is going to become 2 times x plus 2, then 2 times x minus 2. You notice I'm not putting any operations in between here because that messes up the whole thing. Okay, now I'm going to end up with a factor. If I put a minus sign or a plus sign here, it changes everything. So because it's a product all the way through, these 2's will multiply, so I end up with 4 times x plus 2 times x minus 2, which means that if you had taken out the GCF at the beginning, right, in this case 4 is a common to both, so I end up with 4 times x squared minus 4. I end up with 4 times x plus 2 times x minus 2. All right, so pretty, as expected, we're getting what we expected. Okay, what about this example? I have x squared minus x and then minus 12. So remember that this is a product of two numbers, and this is a sum of two numbers. So this is a product, and this is a sum. So what I could do, I just need to find two factors of 12 that when I multiply them, that when I add them, okay, when I two factors of 12, when I multiply them, I get negative 12. And when I add them, I get negative 4. So let me write down the factors of 12. So I know 12 can multiply by 1, 6 times 2 is 12, and then 4 times 3. Okay, and this is where I play around with these numbers using the positive and negative. Okay, so I need a negative 12. If I add, and those two numbers have to add to negative 1. Okay, so what if I had negative 12 plus 1? I end up with negative 11. That doesn't work. If I have 12 minus 1, I end up with positive 11. That doesn't work. Negative 6 plus 2, negative 4. Nope. 6 minus 2 is 4. That doesn't work. I have 4 minus 3 is positive 1. Not what I'm looking for, but negative 4 plus 3 is negative 1. So this is what I'm looking for. Okay, negative 4, negative 3. So I just write my answer as x minus 4 and then x minus 3. So what's the rule there? The first thing I do is I identify what number needs to be a product. Then I find all the factors, right, by multiplying these two pairs of these numbers. And then I check if I also make one negative, one positive, and took their sum, do I end up with negative 1? And it seems like only 4 and 3 work. Or in this case, negative 4 and 3 worked. Negative 4 and 3. So I wrote this wrong. It's negative x minus 4 and x plus 3. All right. I'm going to throw another example on this page. So what if I have x squared minus 5xy plus 6y squared? Okay. Remember, these numbers, I need two numbers that add to negative 5. I don't really care about the x and y, just the coefficients. And those two same numbers have to multiply to 6, positive 6. So let's see what we have. The factors of 6 are 6 and 1, 3 and 2. Okay? Because the product is positive and the sum is negative, both the numbers will be negative. All right? So I don't need to test out negative and positive. It's just negative numbers. So these two will be negative. Okay? Negative 6 plus negative 1 is negative 7. Negative 3 plus negative 2 is negative 5. So this will be the one that works. So when I expand it, I end up with x minus 3, x minus 2. All right, let's look at another example. Quick one. So I have x squared minus 8x plus 16. Okay, so this is one of those examples I was talking about. So I look at 16, and this is 4 times 4, right? Or it's negative 4 times negative 4, right? Because of this plus sign and this negative sign, I know the two numbers. I need two negative numbers that add up to negative 8, and those two negative numbers are going to multiply to positive 16. But I also know that there's a 1 in front. And if I take 2 times 1 and times negative 4, I do end up with negative 8. So remember, it has the form of x minus y, times x minus y. So right off the cuff, I can figure out that this is x minus 4 times x minus 4, which is x minus 4 squared. Okay? If I wanted to take the long way to figure that out, it's the same thing. I need two numbers that multiply to 16 and negative 8. So numbers that multiply to 16. I have 1 and 16, 2 and 8, 4 and 4. So because I need a negative sum and a positive product, all of these are negative. Okay, negative 1 minus 16 is negative 17. This will be negative 10, and this will be negative 8. Okay? So, yeah, sorry, I'm adding these. So negative 1 plus negative 16, negative 17. So yeah, this is the only one that works. So there we go. Another example. Let me squeeze in another example on this page. So if I have x squared plus 10x plus 25. Hey, I'm kind of in the same situation here. So I have, this is 5 times 5. So once you see a square at the end, kind of check it out to see if it follows a rule that you can just quickly jump into. Well, there's a 1 in front, and this middle number is going to be 2 times 1 times 5, which is 10. Okay. Also, this plus sign tells me that the numbers that I'm going to be using are going to be positive. So this just follows the rule of x plus y squared, or x plus y times x plus y, which is in this case x plus 5 times x plus 5, which is just x plus 5 squared. So the rule there, if you can spot these and you can work them out, then by all means do so. Okay, so let's look at a little bit more complicated examples. These are the ones where you have to give more attention to. So I have 4x squared minus 3x minus 7. Okay, so remember what I said, that a being not equal to 1, worst case negative 1 could be a problem. Yeah, this is what I was talking about. So the way that we go about this, and the first thing you could do, we could do trial and error, and you could take a while to guess. But before you jump into trial and error, I want to show you what it looks like, what this product, what the values here actually mean. So we actually have something that takes the form of acx squared plus ad plus bc times x, and then plus b times d. Right? So this is kind of what's happening. So this means that in factored form, it's actually ax plus b times b, no, not b, cx plus d. So that's what it looks like in factored form. In factored form, when we expand it, we end up with something that looks like this, right? So essentially, we got to break down our equation into this form. So one method is to use, this little chart thing that I'm gonna draw, and it goes like this. Okay, so we have ax and b, then we have cx and d. So remember, in factored form, when I factor it out, I'm going to take these values. When I factor it out, my first set of brackets will have these values, and my second set of brackets will have these values, meaning whatever the numbers are. So this will represent ax, this will represent b ax, this will represent cx, and this will represent d. Now, the method that I always use is that I need to find two numbers that multiply to a. So my two numbers are going to be here. These two numbers need to multiply to a. All right? And these two numbers, when I multiply b times d, I'm going to end up with 7. Okay, so I mean, if I follow this form, these two numbers multiply to AC, if you want to call it that. But really, they should multiply to this 4. And then B times Z should multiply to this 7. Okay? The last part is, which is where it gets a little bit wonky, is that if I take A, those two numbers, okay, if I take these two numbers and I multiply them, right, based on this, and I take these two numbers and I multiply them based on that, and then I add them together, I'm going to end up with -3. So this is not very. This is if you're going to use this method, you're going to be doing a lot of trial and error. And I'll go through and I'll solve this example using trial and error. What I want to show you afterwards is a couple methods, one the MAXX method and the box method, to make this a lot easier so you're not doing a lot of guessing. All right, so let's go ahead and let's guess our way through this. So our first thing is we're going to guess. Okay, so I need two numbers that multiply to 4. And these are going to be on the vertical in this left column right here. So I'm going to, they're both positive, so I'm going to pick 4 and 1. Okay, easiest one, I'm going to start with 4 and 1. I could pick 2 and 2, but I'll start with 4 and 1. Then I need two numbers that multiply to -7. And one of them has to be negative, and one has to be positive. So I'm going to start with 1 and -7. So remember, if I cross multiply and add, I should end up with -3. So what do I have? I have 4 times -7, which is -28. Then I have 1 times 1, which is 1. That doesn't work. Okay? So this is why this method is messy, because you could be trying for a long time and there's no you just have to keep guessing. Okay, what if I was to go, get discouraged and I say, okay, let's try 2, 2, 1, -7. So now I have 2 times -7, which is -14, plus 2, which is -12. That's not going to work. So let's try another one. 2, 2, -7 on top, and then 1 below. I'm back to where I started. I have 2 minus 14, which is -12. So this doesn't work. So let's go back to my 4 and 1. So I'm going to go 4, 1, and I'm going to go -7 and 1. And this now gives me 4 minus 7, which is -3. Whoa, this works. So I found my values. So now I'm just going to write them out. Remember, the way I write them out, I just grab the horizontals, the horizontal values. So that's one set of values, and this is the other set of values. So I'm going to write them out exactly as they are. So the factored form becomes 4x minus 7, and then x plus 1. Okay, good. Okay, so let's look at another example, but I'm going to show you what they call the MAXX method. I think I might be misinterpreting that, but it's called the MAXX method. And this one I find a little bit easier to work with. So if we have 6t4 plus t squared minus 12. Let me just take a minute here. So with the t's, the 4 and the 2 tells me that all I'm going to end up with is, say, something t squared plus something, and then something t squared plus something, right? Or minus. Ignore the minus sign for now. So as long as the biggest degree is twice as much as the second degree, then you have nothing to worry about. If that wasn't the case, if you had T5, and then, so if you had 65 plus T3, this, you couldn't factor this, right? It wouldn't work out. Or there has to be another way for you to factor it. So we're in good shape. Just check that it's double. All right, so let's get rid of that so we have the space to work with. All right, so here's what we're going to do, the max method. So the first thing we're going to do, let's just label these. So I have A, B, and C. And A, B, and C are the numbers in front of the terms or the coefficients. So A is 6, B is 1, and C is negative 12. So step one, we're going to multiply. You know what, I want to write it over here so I have more room. So we're going to multiply A times C, and that is 6 times negative 12, which is negative 72. So that's the first thing we do. The second thing is we need to find all the factors of negative 72. And they are, we're going to find the two numbers that multiply to get to negative 72. But for now, let's ignore the negative sign and just focus on 72. So I know I have 1 and 72. I have 2 and 36. I have 3 and 24. I have 4 and 18. I have 6 and 12. And I have 8 and 9. Those are all the factors. Okay, once I have that, then what I need to do now is check which pairs of factors add to B, right? And then keep in mind the negative signs. Okay, so this just means that you might have to just sum a bunch of numbers alternating the negative sign. And what I mean by that is you're going to want to do, and I did this in the previous example, you're going to want to do, because, 72 is negative, and when you multiply the two numbers, one has to be negative to get you negative 72. But because B is 1, the bigger number has to be positive. Okay? So if I go 72 and minus 1, that's 71. If I have 36 and minus 2, that's 34. So those big numbers aren't working. So clearly the one that gives me the best result, that's closest to 1, is 9 and 8. 9 minus 8 is 1. So my two numbers that I'm going to use are 9 and 8. These are going to be my product. So that's where the M comes in, right? So I should have wrote this. We're doing the max method. This is where the M comes in. So my M is going to be 9 and negative 8. Okay, and this is going to give me my negative 72. My sum, which is A, is going to be 1. I know that. 9 minus 8 equals 1. So now I got to figure out what my X values are. And what you do here is pretty straightforward. You're going to take A, whatever the A value is. I'm going to write it down in the corner. You're going to take A, which is 6, right? A is 6. We're going to write it as AX over the first factor. In this case, it would be 9. And then for the second one, we're going to write it as, okay, so AX, so it's really 6x over 9. Yeah, okay, never mind. AX over 9. And then the second one is going to be AX over negative 8. And you have to keep it like that. So now let's go back to here, and we're going to have, so A is 6, so I have 6x over 9. And then I'm going to reduce. Okay, reducing is critical. And this becomes, if I divide both by 3, I get 2x over 3. And for the second one, I have 6x over negative 8. And if I divide by 2, I have 3x over negative 4. The beautiful part about this is that now I have exactly the numbers I need for my factors. This is going to be my first factor. This will be my second factor. So I'm going to go write it near the question. So it actually becomes, I just write it exactly as it is. So it becomes 2x plus 3. All the signs are there. Everything you need to write it out is there for you. And then 3x minus 4. And if you check real quick, you're going to end up with 2x plus 3x is 6x squared. And I have to apologize. So this is where we have to clean this up. I'm using x's instead of t's. So it's going to be 2t squared and then 3t squared. That you just have to memorize. And keep in mind that you're dealing with t4 and t squared as opposed to x's. All right, so if I go 2t squared times 3t squared, I get 64. 2t squared times negative 4 is negative 8t squared, plus 3 times 3t squared is 9t squared. The sum of those is 1t squared, and then 3 times negative 4 is negative 12. So if you were to work it out, you get back to exactly where you started. Okay, so now we're going to look at the box method. I think the bottom line here is that all of these are pretty tedious. So let's look at this example. We have 8x squared plus 31x minus 4. And this is where these get complicated because you look at them and you're like, okay, how am I going to solve this? But you can't just easily deduce it out of your head. You might be able to, but it's a little complicated. So label these A, B, and C. I don't like how that A looks. So A, B, and C. First thing you do is you're going to multiply A and C. So A times C, which is 8 times negative 4, and that's negative 32. And I'm going to identify B. B is 31. All right. I'm going to go back and I have to figure out what my factors are for 32. So 32, remember I have 1, 32, I have 2, 16, and I have 4 and 8. Those are all the factors. Then I have to think which two numbers where one is negative and one is positive. So your indication here when you multiply 8 times negative 4 is that one of the numbers that have to be negative and one has to be positive to one get this negative sign and then to get this positive sign. Now because 31x is a pretty big number, that means the positive number has to be the biggest one. So right away I know that 32 and 1 work because 32 minus 1 is 31. So that's what I'm going to pick. I'm going to pick 32 and 1. Okay, because I know that positive 32 and minus 1 works. So this is where I come and I set up my box. My box is here. And I'm going to write down the factors that I'm using. So remember, I'm using 32 and 1, but 1 is negative because 32 has to be bigger. And I just put them here. So I'm going to have negative 1, I'm going to have 32. And these numbers, because they add to the number in the middle, they add to B, I'm going to put an X beside each of them. All right? And then now I'm going to take my end numbers, as in A and C, is going to go into, so here is 8, and it's going to be x squared, and then I'm going to end up with minus 4. So you should be able to see what I've done here. I've taken the first value, the last value, and I've taken the middle term and I split it up into a sum. That's what I did. Okay, I kept the first value, the 8x squared, as just exactly as it is in the question. The negative 4 just exactly as it is in the question. But for b, I split it out as a sum. So I have 32x and minus x. The next thing I'm going to do, I'm going to factor along each row. So let me write a note on that. Factor along each row. My writing is garbage in the box. So when I look in this box, I have 8x squared and I have 32x. The biggest factor there is going to be, well, I have x squared and I have x, so I have to take only one x. And then I have 8 and 32, so I'm going to take 8. All right, I'm going to do at the bottom. So I have negative 1x or negative x, and I have minus 4, so I'm going to take a minus 1. That's what I'm doing there. And then I'm going to also factor along the columns. So, actually, no, I'm not factoring. I'm really just dividing. Divide. Yeah, I'm just dividing. Divide in the columns. And what I mean by that is, so I have 8x squared divided by 8x. I'm left with an x. I have 32x divided by 8x, and I'm left with a 4. And you realize that you could do that anywhere. You could divide either this top column or you could divide this bottom column. So negative 1, if I take out a negative 1, I'm going to end up with x. If I take out a negative 1 from here, I end up with 4. So these values now become the stuff that goes into brackets. So 8x squared plus 31x minus 4 factored is going to be 8x minus 1 times x plus 4. And that's all, folks. Good luck with factoring.